A computer is an electronic device that can receive, store, process, and output data. It is composed of hardware components such as a central processing unit, CPU, memory, input, output devices, and storage devices. It operates on instructions and data represented in binary code, and can perform a wide range of tasks including calculations, data manipulation, communication, and entertainment. The history of computers dates back to the early 19th century with the development of mechanical calculators. Mechanical computers were early computing devices that used mechanical components to perform mathematical calculations. Examples include the abacus, slide rule, and mechanical calculators. These devices were widely used prior to the development of electronic computers in the mid-20th century. Charles Babbage, 1791 to 1871, was an English mathematician and inventor who is credited with designing the first mechanical computer, the analytical engine. He is considered a pioneer of computer science, and his work laid the foundation for the development of modern computers. The first electronic computer, ENIAC, was built in 1946. The invention of the microprocessor in the 1970s led to the development of personal computers. Today, computers are an integral part of modern society and continue to evolve rapidly. A basic computer architecture consists of a central processing unit, CPU, memory, input, output, or devices, and storage. The CPU processes instructions and data stored in memory, while I/O devices allow users to interact with the computer. Data and programs are stored in storage devices such as hard drives or solid-state drives. Modern computer architectures also include specialized hardware for graphics processing, networking, and other functions. A computer is typically made up of several key components, including 1. Central Processing Unit, CPU. This is the brain of the computer, responsible for processing data and carrying out instructions. 2. Random Access Memory, RAM. This is the computer's short-term memory, where data is temporarily stored while the CPU works on it. 3. Hard Disk Drive, HDD, or Solid-State Drive, SSD. This is the computer's long-term storage, where data is saved even when the computer is turned off. 4. Motherboard. This is the main circuit board that connects all of the computer's components together. 5. Power Supply Unit, PSU. This is responsible for providing power to all of the computer's components. 6. Graphics Processing Unit, GPU. This is responsible for rendering images and video, and is especially important for gaming and other graphics-intensive tasks. 7. Input, Output, I/O devices. These include the keyboard, mouse, monitor, and other devices that allow the user to interact with the computer. There are other components that may be included in a computer. 8. PCI cards. A PCI card is a hardware device that adds functionality to a computer by connecting to its motherboard's PCI slot. There can be other parts included in computers with more functionalities recently as technology improves day by day. Motherboard. The motherboard is the main circuit board in a computer, and it serves as the central hub that connects all of the computer's components together. It provides the physical interface for all of the other components to communicate with each other, and it also houses various chips and controllers that manage the flow of data and power throughout the system. The motherboard typically includes several key components, including the CPU socket, which holds the processor and allows it to communicate with other components, the RAM slots, where memory modules are inserted to provide temporary storage for data the CPU is working on, and expansion slots, which allow additional components, such as graphics cards or network adapters, to be added to the system. Other important components on the motherboard include the chipset, which manages the flow of data between the CPU, RAM, and other components, the BIOS chip, which contains the firmware that controls the initial boot process of the computer, and various controllers for devices such as USB ports, SATA ports, and audio jacks. Motherboards come in different sizes and form factors, and the specific features and capabilities of a given motherboard will depend on its intended use and specifications. When building a computer, it is important to choose a motherboard that is compatible with the other components you plan to use, and that provides the necessary features and expansion options for your needs. Asus ROG Maximus XIL Hero. This is a high-end motherboard from Asus, a well-known manufacturer of motherboards. It is designed for use with Intel's 10th and 11th generation processors and has features like support for DDR4 memory, PCIe 4.0, and Thunderbolt 3. MSI MPGB550 Gaming Edge Wi-Fi. This is a mid-range motherboard from MSI, another popular manufacturer of motherboards. It is designed for use with AMD processors and supports PCIe 4.0, Wi-Fi 6, and DDR4 memory. Gigabyte Aorus X570 Master. This is a high-end motherboard from Gigabyte, a well-known manufacturer of motherboards. It is designed for use with AMD processors and supports PCIe 4.0, Wi-Fi 6, and DDR4 memory. ASRock B450M Pro 4. This is a budget motherboard from ASRock, a lesser-known manufacturer of motherboards. It is designed for use with AMD processors and supports DDR4 memory and PCIe 3.0. EVGA Z590 FTW Wi-Fi. This is a high-end motherboard from EVGA, a company known for their graphics cards but also produces motherboards. It is designed for use motherboards. It is designed for use with Intel's 10th and 11th generation processors and has features like support for PCIe 4.0, Wi-Fi 6, and DDR4 memory. These are just a few examples of the many motherboard models and manufacturers available on the market. Other notable manufacturers include ASRock, BioStar, and Supermicro, among others. The CPU, Central Processing Unit, is the brain of the computer, responsible for executing instructions and performing calculations. A CPU is a small, square chip that is typically located at the center of the motherboard, and it is one of the most important components in a computer. There are several manufacturers of CPUs, each with their own product lines and technologies. Some of the most popular CPU manufacturers include 1. Intel. Intel is the largest CPU manufacturer in the world, and its CPUs are used in a wide range of computers, desktops to servers and data centers. Intel CPUs are known for their high performance and power efficiency, and they are used in many popular computer brands, such as Dell, HP, and Lenovo. Main CPU models are Intel Core i9, Intel Core i7, Intel Core i5, Intel Pentium, Intel Celeron. 2. AMD. AMD is another popular CPU manufacturer, and its CPUs are often used in gaming and high-performance computing applications. AMD CPUs are known for their strong multi-performance and competitive pricing, and they are used in many popular computer brands, such as Asus, MSI, and Acer. CPU models include AMD Ryzen 9, AMD Ryzen 7, AMD Ryzen 5, AMD Threadripper, AMD Athlon. 3. ARM. ARM is a manufacturer of low-power, energy-efficient CPUs that are commonly used in mobile devices such as smartphones and tablets. ARM CPUs are designed to consume very little power, which allows them to provide long battery life in mobile devices. Available CPU models are ARM Cortex-A78, ARM Cortex-A77, ARM Cortex-A76, ARM Cortex-A53, ARM Cortex-XA7. IBM is a manufacturer of high-performance CPUs that are commonly used in enterprise-level servers and data centers. IBM CPUs are known for their reliability, scalability, and high-performance computing capabilities. Available CPU models are IBM Power 9, IBM Z15, IBM Power 8, IBM Z14, IBM Z13. Enterprise-level servers and data centers are large-scale computing infrastructures used by businesses to store, process, and manage data. The specific CPU model that is best for a particular use case will depend on factors such as the intended application, budget, and performance requirements. When choosing a CPU, it is important to consider factors such as clock speed, number of cores, cache size, and power consumption, as well as the compatibility with other components in the system. The chipset is a collection of electronic components on a computer's motherboard that manages the flow of data between the CPU, RAM, and other components. It acts as a bridge between the CPU and other components, and it is responsible for coordinating their interactions and ensuring that they work together smoothly. The chipset typically includes two main components, the North Bridge and the South Bridge. The North Bridge is responsible for managing communications between the CPU, RAM, and the graphics card or integrated graphics processor. It controls the high-speed data transfer between these components, and manages the flow of data between the CPU and RAM. The chipset also includes various controllers for specific components, such as the hard disk drive controller, which manages the flow of data to and from the hard drive, the USB controller which manages the flow of data to and from USB devices, and the audio controller, which manages audio input and output. The specific features and capabilities of a chipset will depend on the manufacturer and model of the motherboard. When selecting a motherboard, it is important to choose one with a chipset that provides the necessary support for the components you plan to use, and that is compatible with the CPU and other components in your system. Intel is a leading manufacturer of chipsets and motherboards, and its products are often used in computers that feature Intel CPUs. AMD is another popular manufacturer of chipsets and motherboards, and its products are often used in computers that feature AMD CPUs. Nvidia is a manufacturer of chipsets and motherboards that are specifically designed for gaming and high-performance computing applications. MSI is a manufacturer of motherboards that are known for their high performance and reliability. MSI motherboards are often used in gaming systems and workstations, and they offer a wide range of features and capabilities, including support for high-speed memory, multiple graphic cards, and advanced overclocking. Clock rate refers to the speed at which a computer's processor can perform operations, measured in GHz, (GHz). Overclocking is the process of increasing a computer component's clock rate to achieve better performance.